Hi Geo H, this is Unit 3, Lesson 10, and we're just going to do some additional practice with triangles, try and sum everything up that we've done so far. So here's a little summary, see if you can fill this out, and pause the video and see if you can answer the first couple questions. Let's see what you know, and then you can play it for us. I'll play the video and make sure you got it right. So first thing we want to do is list the 5 ways of proving triangles are congruent. And that is side, 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 which to me is the easiest one. Side, angle, side, angle, side, angle, 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 side, and the last one, hypotenuse leg. Remember, for the hypotenuse leg, that's the last one we just did yesterday. You have to say that you have right triangles in order to have hypotenuse leg. What 2 sets of criteria cannot be used to prove triangles congruent? Angle, side, side is not a reason. It's not guaranteed to make the triangles congruent. And then angle, angle just proves they're similar, and that will actually be the next unit. In order to prove a pair of corresponding sides or angles are congruent, what must you do first? Must prove the triangles are congruent first. Once the triangles are congruent, then the corresponding angles and sides will be congruent. What abbreviation do I use to state that the corresponding parts, sides, or angles are congruent? That's that CPCTC, corresponding parts of congruent triangles are congruent. All right, so I'd like you guys, this is really just a summary, so I'd like you to pause this and see if you can try these proofs on your own, and then you can play the video to check what you have. All right, so this first one, I know that there's my given, NQ is congruent to MQ, and I'm going to mark my diagram for that. NQ is congruent to MQ, and I know that PQ is perpendicular to NM. Oops, that's actually all step 1. That's all my given. Could I list them as 2 separate steps? Absolutely, but you don't get more points just for having more steps. Remember, perpendicular lines form right angles. So I'm going to call these angles 1 and angle 2 right there. I just find it easier to use numbers. I don't say they're congruent yet. First I have to say that they're right angles, and that's because I had perpendicular lines, so definition perpendicular lines. Then I can say that they're congruent to each other because all right angles are congruent. I'm just trying to prove the triangles are congruent here. So I always have to look to see if they share a side or if they're vertical angles. And this particular triangle has a shared side. All right, I had wanted you to try this before, so I am going kind of fast on going over it. But if you need to pause the video, then please go ahead and pause it. And then my triangles are finally congruent by side, angle, side. Mark your diagram as you go along so you make sure you can see why the triangles are congruent. Okay. Next up, again, pause the video, see if you can try this on your own. I know that angle 1 is congruent to angle 2, and angle A is congruent to angle E, and C is the midpoint of AE. So far, the first 2 are just some basic proofs to make sure that we're good with everything that we are doing. I'm marking my diagram. Angle 1 is congruent to angle 2. Angle A is congruent to angle E. And C is the midpoint of AE. If it's the midpoint of AE, it's cutting AE in half. So after you have a midpoint, you're just going to say which 2 halves are congruent. The left half AC is congruent to the right half CE. Definition midpoint. And my triangles are congruent. Look, I have angle, side, angle. So triangle ABC is congruent to triangle EDC by angle, side, angle. And then once my triangles are congruent, then the rest of the corresponding sides and angles are congruent. That's my last step. BC is congruent to DC, CPCTC. Okay, nothing so bad so far. All right, this one's a little bit different. QP is congruent to RS, and QR is congruent to PS, and I want to prove that QR and PS are parallel and QP and RS are parallel. So basically I want to prove the top is parallel to the bottom and the left is parallel to the right. And the hint, draw QS. So I'm going to draw this line. Now notice when I draw that line, I now have created two triangles and they share that side. So I can say that those triangles are congruent because look, I've been marking everything that they told me in my given. Those triangles are congruent to each other by side, side, side. So I put my given, and that was QP is congruent to RS, QR is congruent to PQ. They share that side. QS is congruent to QS. All right, and that was reflexive. That's just an auxiliary line that we added, and that's okay. My triangles are congruent, so triangle PQS is congruent to triangle RSQ. I'm trying to put the letters in the right order, which is why I hesitated a little bit. The triangles are congruent by side, side, side. Now, once the triangles are congruent, these corresponding angles 1 and 2 are congruent, and these corresponding angles 3 and 4 are congruent by CP/CTC. I actually need both of them. I need 1 congruent to 2 and 3 congruent to 4 because, and the reason is CP/CTC. Now, if they're congruent to each other, so if 1 is congruent to 2, those are alternate interior angles, that would prove that QR is parallel to PS. And if I had 3, let me get a different color. If I have angle 3 congruent to angle 4, then that would prove that these sides are parallel to each other. Okay, so since 1 and 2 are congruent and 3 and 4 are congruent, then that now makes QR parallel to PS, that's the top and the bottom, and PQ parallel to SR. If alternate interior angles are congruent, then the lines are parallel. Okay. And we have one more page just to try some different ones out. So this is going to get a little bit harder than the ones that we did in the beginning. So basically, ED is congruent to FD. Let's find ED. Oh, ED is this whole side. ED is congruent to FD. So this whole side is congruent to this whole side. EB, the lower, the part of that side, is congruent to the other part of that side. And DA bisects EF. If DA bisects EF, then that makes EA congruent to EF. Makes EA congruent to AF. I want to prove that triangle BAD, and I'm going to highlight these. BAD is this one right here, all right, is congruent to, sorry about the dog, CAD, this guy right there. So I'm going to try and prove those triangles are congruent to each other. So it says, first draw out a diagram to plan how the proof will work. Work backwards by thinking about what you will need and what you will know. Then sketch out a rough plan of how to attack this proof. I don't really have anything in the yellow or the green triangle to help me. Besides the fact that they share AD, I have nothing else. But I have lots of stuff in this triangle. Let me make them a different color. I'm going to make them like orange. I have lots of stuff that I could prove this triangle congruent to this triangle. In fact, I'm almost done. So this proof is going to be a little bit different in that I'm going to first prove triangle EAB is congruent to triangle FAC, and then I'm going to use CPCTC to say that AB is congruent to AC, because AB and AC are part of the yellow and the green triangle. And then they have the shared side, so that's easy. And then I can get this side here, BD and CD, by subtraction, because I already have the whole side and I have the lower half. Okay, so that's my plan. And then I'll finish what I just said. Subtraction to get BD congruent to CD. So basically, you are using different triangles than what you're ultimately trying to prove congruent. But if I prove the other triangles congruent, I can use the parts of those to help me prove the triangles I really want congruent to each other. All right, so now we talked about I was going to get those orange triangles, EAB and FAC congruent. My given is step 1. And my given is everything that they told me. Let me scroll back to my given. So I know that ED is congruent to FD. That's a side, perfect. I know that EB is congruent to FC. And I know DA bisects EF. Now one of the reasons they told me that whole side congruent to that whole side is because that actually makes it an isosceles triangle, and angle E is congruent to angle F. So the outermost triangle EDF, is an isosceles triangle. Angle E is congruent to angle F because the base angles of an isosceles triangle are congruent to each other. Okay? Now I can say that I almost forgot a step. EA is congruent to AF. I marked it on my picture already. You have to be careful that just because you mark something doesn't mean it is you don't need to say it in the proof itself. Marking it is for you. You must make sure you write it in the proof. EA is congruent to AF, definition of bisector. Now I can say that orange triangles are congruent. Triangle BEA is congruent to triangle CFA by side angle side. So that was my plan, to get the orange triangles congruent. Now I can say AB is congruent to AC, okay, by CPCTC. And AB is part of the yellow triangle and AC is part of the green triangle, so that's helping me out. I can say that they share AD, so AD is congruent to AD, reflexive property. Okay, and I can say that BD is congruent to CD by subtraction. Let me just show you what I subtracted. So basically I took ED and FD, and I subtracted out EB and FC, and that leaves me with BD congruent to CD. All right, so let me mark that. So now I know these guys are congruent to these. I'm up to 4. I got a lot congruent going on here. Now I can say the triangles that I wanted to prove, I can say that they're congruent. So triangle BAD is congruent to triangle CAD by side. So this was definitely a more challenging proof because I really didn't have much in the triangles that I was trying to prove, but I used different triangles to help me get some sides for the triangles that I actually wanted. All right, and that was it. So we're all set. We're going to practice some more tomorrow, review, and you should be all set.